Hello, guys. Hello again. Today we're going to do this question. This is September 2025 preparatory examination. Now I'm going to show you all that I just explained previously. So this is the question. I believe everyone sees it. Okay, on this question, guys, it reads as follows. The graph below represents the maximum kinetic energy of an electron, Kmax, ejected from the surface of a metal as the frequency of light shown on it is increased. So as you can see, the graph is of that nature. I'm just going to pause to see. Okay, so if I can just roughly, okay, let me write for you. This is question 10, trial exams 2025. All right, we have a graph there on the question paper of this nature, like we have lines like that. We have an X there. We have a value here, 10. And then somewhere between 6 and 8, we have something there. And then it's like that. So we have frequency here in times 10 to the power 14 hertz. And we have maximum kinetic energy there in joules. Okay, we have something like that. So question number 10.1, it says define threshold frequency. So your answer for threshold frequency okay, what is that? This is simply minimum frequency needed to eject electrons on the metal surface. Here, guys, 2 marks is guaranteed if you can just write as that. Then we go to question number 10.2. It says, write down the threshold frequency of the metal. So now I have to look, I want to show you here. So between 0 and number 2, they are about 1, 2, 3, 4, 5 squares. So what I want you to know is, if you are given a graph, you must use your common sense. That means each square there is divided into 2 in half. So in other words, each square is 2 times. So that means that there are 5 is 10. So in other words, we can just say in the middle, in 2,5, there we have number 1. We have number 1. So in other words, here we have 6,1, 6,2, 6,3, 6,4, and we have 7 here. That is 7,2. That means the value there, because they said write down. You have to use your common sense now here. So that means there is going to be 7,2 times, they said times 10 to the power 14 hertz. There is no need to calculate. They just simply said write down, they said write down the threshold frequency. I said that value there on the previous video. I was representing the graph that this line, when it touches the x-axis, that is the threshold frequency. So here you must determine that threshold frequency using your common sense, using these smaller squares here. From 0 to 2, so how many these squares? 1, 2, 3, 4, 5. So it's 2 here. That means in 2, it's like between, when you divide this one by 2, it's like 2,5. There is 1 here. So in the middle here, it's 7. That means it's 7,2. So that's it. Done. The 1 mark there, guaranteed. Let's move on to 10.3. Determine the value of x as indicated on the graph. That's 4 marks now. You see that? That's 4 marks. So, what might be the value of x? Looking at the graph, x is on the y-axis and frequency is on the x-axis. So this is an dependent variable, independent variable in this case. That means this value must be the same value here. That means what is the value of the maximum kinetic energy? Here, I think you remember the equation I showed you previously. That's it. This is the same as the value of x there. Are you with me, guys?
Yes, sir.
Now, what we're gonna do is, first thing first, we know the what you call it, the value of the frequency there. You remember that value there? I said that's gonna be the value of the incident frequency. So, if you remember previously, I said E is equal to H times F. That is Planck's constant times incident frequency. So that means I will just substitute there. I will simply say Planck's constant, you know, all of you guys know it's 6.63 times 10 to the power minus 34 times that value there, which is 10 times 10 to the power 14 equals to threshold frequency. Now is simple. We know the Planck's constant again. You remember I said work function is Planck's constant times threshold frequency. Planck's constant is a constant. On your question paper, all the constants, you find them there. There is H. You see, there it is there. Don't think I'm too smart. I just, everything you got it there, okay? Now, what is the threshold frequency there? That's it. We found it there. We say now 7.2 times 10 to the power 14 plus, let's assume this is x, because that's what we are looking for. If you look at this, it's straightforward. You make x the subject of the formula. X, which is the maximum kinetic energy, is equal to now 6.63 times 10 to the power minus 34 times 10 times 10 to the power 14 minus 6.63 times 10 to the power minus 34 times 7.2 times 10 to the power 14. And then blah, 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 blah. You find yourself that value. You see that? All of you, I'll give you a job to find that value. That's up to you. Now let's move on to 10.4. In order for you to understand 10.4, the concept of intensity and frequency. When they say the intensity is increased and the frequencies remain the same, and the frequency is increased and the intensity remain the same, I will talk to you about that on the next episode. For today, I just wanted to show you how to apply the graph I've previously explained. I love you all guys at home. I hope you excel in physical sciences. See you on the next episode. Bye.